am talking about diffusion tensor imaging. First of all, introduction. Diffusion tensor imaging is a non-invasive tool for studying white matter composition. The contrast in DTI is provided by water movement within tissue. Diffusion tensor metrics are surrogate markers of normal age-related maturational changes and disease states that affect the composition of white matter, thereby affecting the diffusion of water. It is common for DTI to be processed using a single tensor model, that is, to assume there is only one dominant fiber direction within its voxel. Now we first of all look overview of diffusion. It is a self-diffusion of molecule has been studied with magnetic resonance methodologies for several decades. With respect to physical principles underlying diffusion, that is also known as Brownian motion, water in tissues with an oriented structure tends to diffuse more along the orientation of tissue structure. The incoherent motion of the diffusing water, when it occurs in the presence of magnetic field gradient, leads to diffusing of MR signal. This diffusing produces signal attenuation, which is related to the magnitude of diffusibility of the water along the direction and magnitude of the applied gradient in an exponential fashion. In first image we can see there is free diffusion, whereas in image B we can see restricted diffusion, which are restricted. Now diffusion detects the molecular motion of water and allows for quantitative assessment of the freedom of diffusion. The addition of two strong symmetric gradient to the EPI spin equisequence help in differentiating of stationary from mobile water molecule. And if there is any net movement of spin, that is, if diffusion occur between the two gradients, single attenuation occur. Here we have first 90-degree RF pulse and then 180-degree RF pulse, and in between, in both sides of the 180-degree RF pulse, there are two motion probing gradient are applied. After phase encoding, then readout gradient is used to collect the signal, and if diffusion of water molecule occurs between these two by motion probing gradient, then the signal will lose. Here we have two. First gradient is applied, and after that 180-degree RF pulse is used, then second gradient, and if there is no motion, then the dephasing created by first gradient will be overcome by diffusion dephased by second gradient, and there will be no signal loss. But if there is motion between two gradients, then there will be signal loss. Now we talk about isotropic and anisotropic diffusion. First of all, isotropic diffusion is diffusion which is same in every direction and is characterized by single diffusion coefficient, whereas anisotropic diffusion varies with direction, so it is called anisotropic and is characterized by diffusion tensor, a 3×3 matrix model. B value represents the strength of the diffusion sensitizing gradient. The B value depends on strength, duration, and the spacing of the pulse gradient. Larger the B value is achieved with increasing the gradient amplitude and direction, and by widening the interval between the gradient pulse, more will be the diffusion strength. To sense slow moving water molecule and smaller diffusing distance, B value should be higher. For example, B value is 1000 second per millimeter square. The unit of B value is second per millimeter square. A useful rule of thumb is to choose the B value such that B product of B value and ADC is nearly equal to 1, and ADC is inherent properties of the tissue, whereas B value is extrinsic. Here B value is given by gamma square, that is gyromagnetic ratio, capital G amplitude of the gradient, delta length of time of gradient, that is delta square, and triangle, that is distance between two gradient, minus delta by 3. Now apparent diffusion coefficient, that is ADC, measures area of water molecular diffusion in 1 second and is expressed in millimeter square by second per second. Reduced ADC occurs in acute stroke, abscess, cellular neoplasm, recurrent tumor, whereas increased ADC in benign lesion, necrosis, post-radiation changes. Since MRI cannot distinguish molecular motion arising from differences in concentration gradient from that resulting from temperature gradient or other reasons, the coefficient is apparent and not a true value, so it is called apparent diffusion coefficient. Next is exponential apparent diffusion coefficient or exponential ADC, derived from dividing diffusion weighted image by T2 image to remove the effect of T2 sign through. True restricted diffusion occurs dark on ADC and bright on exponential ADC. ADC or EADC, that is exponential ADC map, can be used depending on whether we want contrast to match or be opposite to the diffusion weighted image. Okay, this much for today. Next we will see on next videos. Thank you.